Probably won't surprise you to learn that up to 40% of the marks in exams can be for calculation questions, and I'm going to look at the exam technique for answering these sorts of questions in this short video. So when you first look at a question involving a calculation, and this one is from an Edexcel dual award or separate science paper, it's good to read through the question and identify the data. So a weightlifter lifts a bar of mass of 240 grams. I suggest you highlight the points where there are data, through a vertical distance of 2.5 meters. I might also annotate the diagram at this point just to remind myself that it's lifted a vertical height there of 2.5 meters. So having identified the data, you need to pick a suitable formulae, and some formulae you have to learn and others are given for you on the exam paper. So this is one you have to learn. The gravitational potential energy is equal to mass in kilograms times by g, the gravitational field strength, which is given on the front of the exam paper, and a height, or h. So substituting in the numbers that we've just identified, a mass of 240 kilograms multiplied by g, 10, which is on the front of the exam, times by the height of 2.5. And that gives you an answer of 6,000. Now with calculation, so long as you put the units into an equation in standard form, in standard units, you get an answer out in standard units. So because we use mass in kilograms, and g is the constant in newtons per kilogram, and height is in meters, all of which are standard units, the answer comes out in the standard units for energy, which is joules. Some questions would give you a further mark and asking you to remember the correct unit for energy. Make sure that every quantity always has a unit. Let's move on to the second part of this question. So it says, she then lowers the bar halfway, stops and drops the bar. Calculate the loss in gravitational potential energy in joules of the bar when it is halfway down. And again, I've just highlighted some key words. So once again, the formula we're going to need is gravitational potential energy is mass times by g times by height. And this time we're interested to know how much energy has been lost when it has fallen half of the way down. So the height is going to be half which it was before. So that makes the calculation as follows: 240 multiplied by 10 multiplied by 1.25, half of the original height. So that gives us an answer for the loss of 3,000 joules. Now it shouldn't surprise you that the loss is half of the original amount of energy, because the formula for energy is m times g times h. Energy is proportional to height. So if the height reduces by a half, the amount of energy has reduced by a half. The next part asks you to work out the remaining gravitational potential energy when it is halfway down. So if we take the original amount of energy, 6,000, and subtract the amount that we have lost, 3,000, we get 3,000 joules. It shouldn't surprise you that the amount of energy that you have remaining is again half of the original, because it's now half of the way down. Now the final part of this question wants you to calculate the speed or velocity in meters per second, so that's a standard unit, of the bar just before it hits the floor. Now just before it was dropped, we've calculated its gravitational potential energy, and we can assume that all of the gravitational potential energy is going to go into its kinetic energy. So we can say that the kinetic energy is equal to the gravitational potential energy here. And we can make this assumption for things which fall through air over short distances and things that are compact for their weight. So there's very little air resistance. So here I've just stated that that is equal to 3,000 joules. Now the equation for kinetic energy that you had to recall is a half mv squared, where v is the velocity. And you need to rearrange this equation to make v, or initially v squared, the subject. So let's do that little bit of algebra. So rearranging gives velocity squared is equal to 2 times the kinetic energy over the mass. I would always rearrange the terms algebraically using the letters rather than substituting in the numbers. I think people find that easier and make fewer mistakes. So on the next line I would write 2 multiplied by the kinetic energy, which was 3000 joules, divided by the mass, which is 240 still, equals 25. And because I've written that all on one line, with the subject here still being v squared, I know that I've worked out v squared here and not just v. So the final line I need to take the square root to calculate v. So you see on the final line I've taken the square root and put the answer here into the box. If this question had been worth 4 marks, the 4th mark would have been for giving the final unit as meters per second. So to summarise, when doing calculation questions, highlight the data, make sure that it's in standard units, for example meters for distance, not kilometers, and seconds for time and not minutes or hours. Next, find the appropriate formula and write it down. Substitute in your numbers and be meticulous with your algebra. Check your answer twice using a calculator. And remember to always state the unit. And finally, remember that there are always marks available for error carried forwards. If you don't know how to do one previous question, substitute in a random number, and although you get that mark wrong, you'll get marks for any further questions that you have to use that figure for. Hope that helps.